Welcome. My name is Randy Jenny, and this is a short video demonstrating a loan schedule. It's aimed at MacEwan University students taking business computing, and you can download the Excel highlights file using the link below. So here's the idea of this spreadsheet. We're buying a condo, and we put some money down, but the balance we owe is $250,000. We're going to try to pay that off in 20 years. The interest rate is 5% annually, and we're going to make a payment every month. So I'm going to start in cell C9 here, and I'm going to use the payment function. So I'm going to go Insert Function. I'm going to click in the lower region, type PM, and bring up the payment function. So first I need the rate. So that's my 5%, but that's an annual interest rate, and I need to divide by 12 to get a monthly interest rate. The other thing is, I'm going to try to think a little bit further ahead, and I'm going to realize that when I start to fill this formula down, I don't want the B4 to change to B5, B6, B7. I want to anchor this cell reference. So while I'm building this formula, I'm going to try to remember to make the cells absolute that need to be absolute. So I'm going to press F4 and then do my divide by 12 to get my monthly interest rate. N per, total number of payments for the loan, that's going to be my 20 years. Again, I'm going to make that absolute, times 12. So 20 years times 12 payments per year, that's going to give me the total number of payments for the loan. And present value is my $250,000. That's how much I presently owe. And again, absolute. And that's all I need. These other two parameters are not bolded, and that's an indication that these are optional parameters. So I'm going to click OK, and it shows me my monthly payment. I don't really want to see it as a negative, so I'm going to use the little trick of putting a minus sign just after the equal sign in the formula. 1649. Now, sometimes what I like to do is fill it down a few cells just to make sure that things are working properly. If I've forgotten to do some of the absolute values when I'm building the formula, usually it becomes very obvious and kind of painfully obvious when you fill the formula down a few cells. And that's your clue to go back to the original formula and check each cell reference and ask yourself whether it needs to be relative or absolute. Okay, I'm going to move on to the monthly interest. So of that 1649, some portion of it is going to be interest, and some portion is going to be principal. So those two together will make up the 1649. But interest is going to change over time. On the very first payment of the loan, I'm going to be paying a higher amount of interest, but that will decrease over time. And how much is going toward principal will increase over time. So we'll see if I can build that. So monthly interest, I'm going to go Insert, and this time it's going to be I payment. So if I type in IP, it jumps down to I payment. So that's the interest portion of a payment. So three of the parameters here are the same as they were for the previous function. So the rate is going to be the 5% absolute divided by 12. I'm going to skip over the next parameter and do N per, because it's one of the ones that was the same as it was for the payment function. So N per, total number of payments, is going to be my 20 years, absolute, times 12. And present value is my 250,000, absolute. I'm going to come back up here to per. Per is the period for which you want to find the interest and must be in the range of 1 to the total number of periods. So what I want to specify is this payment number over here. That's how it will know that the interest is going to decrease over time. So if I refer to the payment number B9 and I don't make it absolute, it will change from 1 to 2 to 3 to 4 to 5 when I fill this formula down. I'm going to click OK. It shows up as a negative, but I can change that to a positive by putting the minus sign in. And it tells me that of the 1649, 1,041 of it is interest. A little bit discouraging, but correct nonetheless. Now, I happen to know that the P payment function, to figure out the principal portion of the payment, is identical in nature. In other words, it uses exactly the same parameters as the I payment function. So I'm going to use a little cheat here. I could build it manually using exactly the same technique as I used for I payment, but I'm going to use a little trick here. I'm going to highlight the I payment function, click and drag over top of it, and copy it. So I'm going to do Control C. I'm going to hit Escape so that I don't mess up that formula. And I'm going to go over here, and I'm going to paste that formula in. So of course I get exactly the same result because I did a copy and paste. But now, here's the trick. If I go up and change I payment to P payment, so it's a function that uses the same parameters, but it's designed to figure out the principal portion of the payment, not the interest, then I get 608. And I can kind of tell at a glance, if I do 1,041 plus 608, I'm going to get the 1649. My balance over here is going to be simply equals the original balance minus, and it'd be nice if we could deduct the entire payment, but we can't. All that comes off the loan is the principal, not the interest. So now I should be able to highlight that whole first row and probably even double click. No, I can't double click. I have to drag this one down. So I drag it down to 240 payments. I finish off with a balance of 0. That's encouraging. And if I go back up to the top, sure enough, total of all monthly principals was 250,000. Total of all the interest, sadly, was 145,000. And that's it. Thanks for watching.